Hey everybody, we are getting ready for the Kahoot right here. Let me make sure I have the volume at the right levels. Can everyone hear and see me? It's always the fear that no one can see me. What is up, Andrew? Charlie, good to see you here. We have everything about ready to go. Let me adjust this a little bit right here. I don't know why, things change. I need to adjust the... Oh wait, I don't know. It was good. I know, right? It's good to hear the music. It's good to hear the music. Still got the long hair. Things will change eventually. Mohammed can see me. Hey, good to see you here, Mohammed. Jordan can see us. I think we're on a good latency. It's the last Kahoot I know, Dan, right? You should be hearing the music in the background right now. What is up, Kobe? Good to see you here. We'll show the code here in just a second. Let's do a quick latency test. Everyone knows how this works. When I snap, you type 1. What's up, Parker? Good to see you. So get ready. We're going to see how long the latency is. Here we go. Get ready to type 1. 3, 2, 1, go. Okay, there goes snapped. So 1, 1000, 2, 1000, 3, 1000, 4. Go, there we go. Woo, we got like a 5-second latency. Let's get ready to go right here. Let's show that code off. Let's get ready. We'll be starting playing Kahoot in about 3 minutes. I think how many people do we have watching right now? Last I looked, it was like 50 or 60. Let's try to get 100 going here. That's a long code. It's like a phone number. Don't dial that phone number. How many people do we have watching? This is 74. Let's see if we can break 100. Good evening, Kobe. I'm doing quite well. Do we got 2 Kobe's here? I think we do. Olivia's here. Ethan's here. The code is now on the screen. First person is Dazzled Wolf. Dazzled Wolf. And these questions that we're doing tonight, ooh, they're questions that could definitely appear on the test. So many people joining up right now. Smiling something. I missed it. There's so many crazy names. Royal Cat. Winged something. Gentle Gecko. I get 100 people playing. Let's see if we can get 100 playing. Remember, who knows how much money we're playing for tonight? It's craziness. You know, I thought it's Christmas time. It's not Christmas yet. But I was like, you know, Christmas is coming up right here. Why not do a really big Kahoot with a really big prize? Isaiah knows right there, $50. So if you win, make sure to take a screenshot on your phone. Andrew knows $50, $20 second place, $10 third place. And I am doing a Kahoot after this. I'm doing another Kahoot. So you could do the 324.74 Kahoot. Now, you didn't take that class, but you can still do it. You can come in and hang out in the 324.74 Kahoot and see if you win. You never know. You never know. I think our Kahoot is 15 questions. 15 question Kahoot. I got to remember to do the special thing for the last question. Oh gosh, I hope I didn't make a mistake on any of the questions. I have a way I make the questions. I always put the right answer in the top left corner when I'm making it, but then it randomizes what the right answer is. And then last Kahoot we played, I made one mistake. So I'm very sorry if there's any mistakes. Let's hope there's no mistakes. Let's hope. Got Rick and Morty on for good luck today. How is everyone doing? Did everyone have a good Thanksgiving? Good Thanksgiving? Let's choose one more lobby song. I need someone to shout out what lobby song we're going to listen to for our last lobby song, and then we're going to get started. We got a bunch of different ones. Which lobby song are we going to listen to? We got beatbox, trance, reggae, funk, disco. We're on disco. Adventure, fantasy, original, futuristic. Had a pretty good thing. We had a really good turkey. Really good time. Coconut Mall. Oh, that'd be so good. Coconut Mall's so cool. It's got the escalators and stuff. Is that in I'm watching the Cars, the me versus people driving the cars. Is that Coconut Mall? I don't think it's on here. But I think that's the one where the people are driving the cars back and forth at the end of towards the finish line. Am I right there, Alexander? Is that Coconut Mall? It's got like, you go down the escalators and stuff. I think that is. Good. I'm thinking of the right game. That came out on the Wii. So that'd be on the Wii was Coconut Mall. Man, Mario Kart is such a good game. Mario Kart 8, go get that. I keep on thinking about rebuying it, but we had it on the Wii U. And then people are like, the Wii? And I'm like, no, the Wii U. Like, what the heck's the Wii U? And I'm like, it was the system after the Wii. And they're like, oh, so it was like a newer Wii? And I'm like, no. It's the Wii U. It's the system after the Wii. People still don't understand that there was a system after the Wii before the Switch. But with that little factoid right there, who's ready to get started? Let's get some I'm ready's in the chat. We got people dropping. No! Who's ready right now? Who's got some readies in the chat? Remember, we're here to learn. Learn first, win second. Alexandra says she's ready right there. Meryl's ready. Shelby's ready. Got some I'm ready's in the chat right here. Caillou's ready. Clarified's ready. Rocky Top, so good to see everybody. Remember, these are questions that could be on the final. You never know. Let's review some concepts. We'll be starting here in 5, 4, 3, 2, 1. I'm going to do it one more time because we're on latency. 5, 4, 3, 2, 1. So if you're not joined in, the key's still on there. Let's do this. Let's Kahoot. Let's get ready. Here we go. Down here in the corner, I might have to like hide away. Might have to go to a tiny version of myself. Okay, to test the mean, we use a sample size of 98, a standard deviation of 2, and a mean of 3. Find the degrees of freedom. It's a lot of information on the screen right now. So we're testing the mean right here. We're going to use a sample size of 98, a standard deviation of 2, and a mean of 3 is what we're going to find right here. So what are the degrees of freedom? What are the degrees of freedom here? Any ideas? Lots of answers. Lots of answers. Who knows what kind of test this is? So I'll tell you the answer here. It's 97. But who knows what kind of test this was? Who knows what kind of test this was? Which will come up in later questions. This is, and so Dan is right. The degrees of freedom are n-1. And there's a good way to remember this. This is a one sample t-test. So with the one sample t-test right here, we have n-1 degrees of freedom. So there's 3 times we use degrees of freedom for this test. And what's the point of the degrees of freedom? It tells you which distribution you are using. So on the one sample t, we'll show it again here in a second. Mallory, if someone wants to post it. Oh, I'm hiding it. Here, 2 seconds, Mallory. There you go, Mallory. I'll go right here. And there's the code right there, Mallory. You might have to pause the video, but go make sure you're watching live. So there's the code right there. So we have one sample t-test. One sample t. And a one sample t-test is when we're testing one mean, or we're doing confidence intervals for one mean. And the degrees of freedom here is n-1. The 2 sample t-test, so a 2 sample t-test, we don't do this formula. It's a very complicated formula, which I have never solved by hand. But so let's just put complicated formula right here, complicated formula. That's usually how we ask you on the test. Complicated. It's a really complicated formula, but we don't do the 2 sample t-test. And the degrees of freedom by hand. What is the last degrees of freedom we have? It's for the what test? We have the 1 sample t-test, or the interval is n-1 degrees of freedom. The 2 sample is a complicated formula we don't do by hand. What's the chapter we just did where we had degrees of freedom? The chi-squared. Nice job right there, Abigail. Good review. Chi-squared. So the chi-squared is when we have 2 categorical variables, and it's going to be rows minus 1 times columns minus 1. And we'll probably think of a question over this. Columns minus 1. So rows minus 1 times columns minus 1. So you have all of your different tests right here. Let me move out of the way a little bit better. And so here's all the different degrees of freedom right here. The 1 sample t is when you are testing one quantitative variable. And the 2 sample t, let's put a quick note. This will help you out for later in the Kahoot, so get ready. This is a big hint for later. Take a note. The 1 sample t is a quantitative test on one quantitative variable. The 2 sample t is a quantitative y and a categorical x, and the chi-squared is when both y and x are categorical. So some good notes right here on the variable types for each of these tests, and we're going to review this a little bit more, but let's see who's in the leaderboard right here. Let's see who's winning. We just got a lot of information right there. Inspired Zebra inspiring us all with this win right here. Inspired Zebra, good luck. Let's going to find out. Do you think there will be a degrees of freedom test? Oh, no, we won't have you find the 2 sample degrees of freedom on the 2 sample t on the test. No, because we use applets for that. So no, we will not have you solve that. Really good question right there, Dan. Keep asking those questions. Thank you so much, Dan. There will not be a find the 2 sample degrees of freedom on the test. That will not appear because we won't give you the formula. We won't have you do it. Who is going to win with the next question? Let's find out. Question number 2, which is not a condition for the confidence interval for the difference between 2 means? Uh-oh, I need to get out of the way for this. Which of these is not a condition for the confidence interval for the difference between 2 means? So this is a 2 sample t-test because we're comparing the difference between 2 means. Like, let's compare if people own a dog and what their GPA is. Hint, hint, hint for later. But so when we look at this, we have 2 groups and we have 2 means, and we're going to compare the means. So we can see if the people who own a dog have a higher GPA than people who don't own a dog. And the only condition we will not use on here is success failure. Condition 1. Come on, people. I need to see it in the chat. Come on, let's get started right here. Everyone knows condition 1. What's condition 1? Everyone knows it. Random right there. Condition 1 is random. That means we randomly select things. Condition 1 is random. Condition 2. What's condition 2? Every time we say condition 2, there's no order to them, but it's just these are the ones we can like rattle off really quickly. We can say random, 10%. And now I'm going to do it correctly because sometimes I forget. What do we do after condition 2? What do we do after condition 2? What do we do after condition 2? We what? We get to condition 2 and we pause because this is where the game changes. And then we need to ask ourselves, are we dealing with quantitative or categorical data? So when we get right here, you'll notice we're talking about the 2-sample t-test. So let me just kind of erase everything and only look at what we need right here. So when we look at this, the y variable for both of these tests, because this one just has a quantitative y, the y variable, what we're trying to understand for both of these is quantitative. And that makes the condition right here the nearly normal or large enough n. They're both kind of synonymous. Technically, the large enough n is part of the nearly normal, and we use large enough n for the sampling distribution of the sample mean, chapter 14. But this is basically where the distribution should look something like this. And what ways can we do this? This is on the test too. What is one way, and I think I put it on the Kahoot also, what is one way we could check to see if it's nearly normal? What is one way we could check to see if it's nearly normal? So what is one way we could check? What is one way we could check to see if it's nearly normal? Histogram, exactly. That's kind of what I've drawn right here. We could look at the histogram to see if the histogram looks like this. So first way is kind of look at a histogram and see if the histogram looks nearly normal. Another way is with a QQ plot for normality, and we call that a normal probability plot. And that's where it follows the straight line of its normal. Next, we could do a goodness of fit test, and that would hopefully have a high p-value. Something like 0.70 would indicate it's nearly normal. And then Dan brings up the central limit theorem, which is where we say if it's normal looking, we only need a sample size of at least 1. If it's skewed, we need a sample size of 25. And if it's heavily skewed, we need a sample size of 100. So these are the kind of 4 ways right here. 1, look at the histogram. Don't use that pen. 2, use the normal quantile plot. 3, the goodness of fit test. And 4, the central limit theorem right there. So this is a quick hyper review of these topics right here. And this is the nearly normal condition right here. What exactly does the p-value mean? The p-value, and I don't have jump open right now, 2 seconds. So when we get a p-value for this right here, and this should work. Let's open up this data. The p-value is going to tell us whether or not the curve is a good fit. So let's go here and do one real quick. Let's go to distribution, put in Black Friday shopping amount. And if you look at all those outliers, do you think that this curve itself is a really good normal curve? Like, do you think the normal curve is a very good fit on this, or maybe not such a good fit, Alex? And anyone's free to answer. Do you think if I go here and go to fit distribution, continuous fit, and fit a normal to it, do you think that that'll be a really good fit? Maybe not such a great fit, right? Maybe doesn't fit so perfectly. So the null hypothesis for this is that the curve is a good fit. And let's see, what would you do to the null right here? Here's your p-value for the test. So the null is that it's a good fit. What are you going to do with the null right here? What are you going to do with the null with that p-value when you do the goodness of fit test? You're going to do what to the null that it's a good fit? The null is that the normal curve is a good fit. And what would you do to the null now? You'd reject it, which means you would have evidence that the normal curve is a bad fit here. Does that make sense on what the p-value means for the goodness of fit test? So the null is that it's a good fit. So you're like, I'm going to assume for the moment that this normal curve is a great fit for this. And then when we see the p-value, you're like, it looks like it's not such a good fit. I have evidence it's a bad fit. Julio! Oh, everyone give a shout out to Julio right here. Julio is here for our first Kahoot. He's here for the last one for 2-1. So good to see you, Julio. And anytime, hope to catch up with you and hope you're doing well. When the p-value is low, reject the null. When the p-value is high, just let it fly. Daniel saying hey in the chat right there. Julio, I hope everything's going well by you. And so good to see you. Julio, let's see who's in the lead. Andrew says sup right there. So let's take a look right here. Thank you so much, Julio, for swinging by. Let's see who's in the lead. We have right now, the leaderboard just got completely shaken up. Glad Oryx, is that how you say it? Excited Emu, Soaring Eagle. Oh my gosh, so much craziness. Let's find out the next question. Who knows the next question right here? Let's find out. Next question is, when doing a 2-sample t-test, the variables will be what? Now, this is a review question. 2-sample t-test, like when we compare people's GPA by whether or not they own an animal. Or we could compare freshmen versus seniors with how much they weigh. We could compare whether you're born, let's say, in Tennessee or not in Tennessee, and what your GPA is. I don't know. You can choose any 2 variables, but one of those variables must be what? And the other one must be what? One of those variables must be categorical and one must be quantitative. So which one of these is the y variable? Which one of these is the y variable? Which one of these is the y variable right here? Which one of these is the y variable? The y variable, the thing we want to understand in a two-sample t-test will be what? The quantitative, exactly. The quantitative variable. Now, this is a two-sample t-test. Can anyone tell me what technique we're doing over here with quantitative, QQ? What are we doing with two quantitative variables? What technique would we be doing there? Two quantitative variables would be what technique? What kind of graphics? Well, with two quantitative, regression, scatter plots, correlation, all that good stuff right there. When would we be doing chi-squared? Which of these is the chi-squared right here? When would we be doing chi-squared? Chi-squared is for which combination of things? The categorical. That's count data. So the chi-squared is two categorical variables. Nice job, Caroline, right there, Olivia, and so many great answers right now. And then what is this right here? This is another thing we have. So if you're taking notes on these, be like one quantitative variable is when we're doing a what right here. If we have one quantitative variable, which would be our y variable, that'd be a one sample t-test. That is just one quantitative variable, the t-test. Remember, Mr. T's mean. So I'm sure he's a nice guy. Sorry, Mr. T. So very nice guy, Mr. T. And one of these days we're going to get him on the show. Hopes, dreams. Okay, let's continue on here. Let's see who's in the lead. Ooh, leaderboard's tightening up. Top three right there. Julio, tonight we're playing for $50. I don't know if Julio's still here, but we're playing for $50 for first place, 20 for second. So right now, you never know, and it's Amazon gift cards. So Merry Christmas to everybody, but let's see who wins this. Big prizes right here with our last Kahoot. I couldn't imagine being in first. I'd be like, oh, gotta win. It's brand new questions this time too, so you can't look at old Kahoots. Let's see who's gonna win with the next question. Here we go. Which is not a way to check for the nearly normal condition. Oh, we were covering this just a moment ago. Which of these is not a way to check the nearly normal condition? Rick's legs are disappearing. It's going through the multiverse. So this is a review question. Definitely take notes and ignore the typos. It's not wrong because of the typo. But we were mentioning just a moment ago that a histogram can be used to look to see if it's nearly normal. The normal probability plot, if it looks straight, it's normal. If it looks bent, it's not normal. Goodness of fit test, p-value lower than 0.05 means it's not normal. And please, I can't even speak tonight. Please feel free to ask any questions on any of these if you're wondering, and we do try to give some hints. So between questions, you'll see me drop some answers and be like, hey, maybe check this one out right here. But these are the ways we generally check, by looking at the histogram, by looking at the goodness of fit test, and the normal probability plot, and we want these things to be in line. Oh no, I'm so sorry. Let's see who's in the lead right here. Is this going to shake up the leaderboard? Were you Soaring Eagle? Rocky Top? No. The leaderboard just massively changed up right here. Massive change up to the leaderboard. Soaring Eagle just took a nosedive right there. Soaring Eagle will come back, though. This is a tight match. Look at this. Only 7 points separate the leaders right there. Let's find out who wins with the next one. Please ask any questions you have. Let's do this. A researcher wants to examine the true GPA of UT students, GPA students at the University of Tennessee. What type of test will they use? So they want to understand the GPA of students at University of Tennessee. They're not going to compare two groups, intend. And we have to think about what kind of variable is GPA. So GPA is a quantitative variable, and there's just one quantitative variable in this example. So we're not doing two groups. And chi-squared, if I remember correctly, is categorical variables. And right here, regression is two quantitative variables. So we'll be doing a one sample t-test. Who's feeling good about this? Who's feeling good? Like, who's feeling like they're getting this down? I kind of designed this way to drop some hints and help you review, but is it making sense on what you need to identify? Shelby, that's awesome right there. Mubot just failed in the chat right there. But this is what I want you to notice, how we're answering these questions and how we're able to identify, GPA of UT students is one quantitative variable. So we are doing, what's I going to say? Yeah, there we go. Just write the notation. We have this right here. Great work, everybody. And great points, great practice. We're going to do more review this week. I'm going to send out some announcements, but I'm probably going to do like chapter by chapter reviews and try to put them in video format and do them live-ish and take questions. So stay tuned. There'll be more review this week. Also, I want to give a shout out right here. Let me go grab the playlist. But if you haven't checked this out already, we've got playlists that I would highly recommend watching. So I'm going to just give a shout out right here on this question. If you are studying up for the final, we have a practice test 3 playlist. And at the very end of it, I go through every step for hypothesis testing, all the different things you need to know. And the exam is on the 4th. I'm always afraid to say the time. Let me go look at the time. I think we sent it out in an announcement, right? I'm always afraid when I'm in a video to say the times live and then get it wrong because I've accidentally done things like that before. And then everyone's like, you said this. And I'm like, oh, I'm sorry, I messed it up. It's on, I literally was looking at I'll show it here. Fall 2020. I literally have looked at this like a billion times. Is this it right here? There we go. I literally can pull it up that quickly. Okay. Let's show this off real quickly right here. The exam time is, and we put it 30 minutes. Yep. People are saying right there, the window of the exam. We put an extra 30 minutes on the window. Please tell me if your instructor, I figured out what's going on with people having conflicts. You're not supposed to have a conflict with this. Is it still all multiple? It's like the other ones. There'll be multiple choice, numeric entry, all those good things right there, Bryson. So it's just like exam 1 and 2 in its format. There's 30 minutes before and after this. So Claire's 100% right. Like Charlie gave the right time frame right there, but we put a 30-minute plus or minus window on it. I'm just always afraid to like say it by memory and then mess it up, and then people write it down. They're like, wait, Brian said this, and then the other sections are like, Brian, why'd you say the wrong times? I'm like, I'm sorry. So what's happened is, and please contact us if this happened to you. Does everyone notice the makeup 2 time? I finally figured out why this is happening. I think asynchronous courses are using some of these makeup times, and then they're using our time period, but we're a departmental exam, so we're not supposed to be moved. If someone's using a makeup time, they should be open to using another makeup time, because departmental exams, according to university policy, are not supposed to be moved. They're kind of the last thing they're supposed to be moved because it's departmental exam. But please tell us if you have any issues. We'll try to work everything out and get everything going. And yes, but with that, let's see who's in the lead. Who's in the lead right here? Ooh, that leaderboard is so tired there. Fast Hen, fastly approaching everybody. But I want to know who Glad Oryx is. I love finding out who the winners are, and I love asking them about their strategies and how they learn. It's not really cumulative. There are the epic. Cracking me up, epic. There are questions we call tools and techniques, which go over the things you've learned, but they what's up, Tyler? There's no real kind of a cumulative nature to it other than what tool or technique would you use in this instance right here. So with that, let's continue on to the next question. Here we go. To examine the difference between GPAs of students and if they own a dog, what type of test would we use? And this is if somebody owns a dog, yes or no, and what is their GPA? So if somebody owns a dog and what is their GPA? I've given away too many of these answers. Like if you're paying attention, you'd be like, okay, wait. If someone owns a dog is a categorical, it puts people into groups. And they're going to compare the GPAs of the people in these groups. So we need to do comparisons based on different groups, which will mean we have what? Since we're doing comparisons of groups right here, this means... Yes, look at all those people paying attention. I love it. Should we be studying all the Canvas content quizzes or just the ones since exam 2? I would only study the ones since exam 2, and I would only maybe lightly cover some of the previous material. I wouldn't go into great detail to go over everything. Your main thing to know, like with regression, let's say this question, who could write in this moment a question that would use regression? That's what you need to know about regression. That's a tools and techniques question for regression. But what would be something like, I'll write one right now. Let's say we want to compare how much students spend at McDonald's during a semester and how much they spend at Publix during a semester. We want to analyze those two variables, how much they spend at McDonald's and how much they spend at Publix. So that would be a regression type question because there's two quantitative variables. Charlie, perfect example using some R stuff right there. Compare miles per gallon and the cylinders a car has. As long as we do cylinders as a quantitative amount, we don't treat it like groups, because you could technically, but you're totally right, because cylinders is a quantitative number. Would you say the exam is more conceptual or mathematic? I'd say it's about 75% conceptual and 25% mathematics. So how many stripes per mile of road? I think that, yeah. I think that works right there, Bryson, because how many stripes and how many miles? Like if we collect data on like, for this 5-mile stretch of road, there was 100 stripes. I think you're talking about the road, right? And then there'll be two quantitative variables, like how long was the mile of road we collected, and then how many stripes were there on the road. that's both quantitative. So does everyone notice right here we have two quantitative variables? When would you use regression? So it'd be two quantitative variables, Alex. Does that make sense? Regression is used for two quantitative variables. You're all right, Tyler. No worries. And the chi-squared is used for two categorical variables. The two-sample t-test is used when we have a quantitative y and a categorical x, like this question. And the one sample, I have the intro ready to go, and I'll send it to you, Tyler. I'm so sorry. I'm so sorry. I have it ready to go, and I'll send it to you so you can check it out. But I didn't use it tonight. I'm so sorry. And then we have the one sample t-test is for one quantitative. Everything's been so quick lately. We got this, though. Let's see who's in the leaderboard. Glad Oryx is just leading the way right now. Glad Oryx is just totally leading the way. Excited Emu. Wait, what happened to, was it Fast Something? Dazzled Rabbit? Diplomatic Eagle? I'm just surprised that Glad Oryx is just destroying it right now. But let's see if they can keep the lead right here at the next question. While attending UT, people find a favorite place to eat. Favorite restaurant versus year at UT. What test would we use? This is a quick one. This is a 20-second one. Be ready. Favorite restaurant versus year at UT. What test would we use? Favorite restaurant versus year at UT. I forgot to hit 30 seconds. It's one of those quick ones. Are you paying attention? Favorite restaurant. I know, Victoria. I have faith in Victoria right here. This is going to win. How did people know this? What did you identify about favorite restaurant and your year at UT? And I guess because there's multiple groups right here. I'm seeing a lot of people answered two sample t-test. Technically, there is another possible answer. We could use an ANOVA right here, but the two sample t-test would not work. And if we treat year at UT like categorical, so I understand why a few people chose two sample t-test, but if we think of year at UT like freshman, sophomore, junior, senior, then we can have a categorical comparison. If you treat it like a quantitative, then technically we could do something where we're doing like an ANOVA right here. So that is another possible answer. But that was a good tricky one right there. I know this is, who is exactly freshman, sophomore. Nice job, Charlie, right there. Excellent work. We had some regression. So favorite restaurant would not be a quantitative variable right here. So that would not be a regression. But two categorical variables. So who is going to win? Do we still have Glad? Oh my gosh, look at this. There is a 15-point difference between these two right here, and they're leading the way. Excited. I'm going to bet on Excited Emu this time. You know what? We have a rabbit. I'm always betting on the rabbits. Dazzled Rabbit. I know, Victoria. This is a lot of fun. I just can't believe the semester is like almost over. And the biggest thing I can say to everybody is just take, with the break we have right now, try to study in 50-minute intervals and take a 10-minute break, but then switch what you're studying. This is at least what works for me and what I've read works, or what I've heard works, is don't try to study one topic all day long. Study one topic for 50 minutes, then take a 10-minute break, and then study another topic for 50 minutes, take a 10-minute break, and this will let your mind kind of digest the information, and it helps to switch up what your mind is doing, because then you can kind of refocus in and kind of regroup your mind. But don't try to be like, today I'm just doing all statistics. This is the only final you have, then devote all your time, Rocky Top, to this. Devote all your time. Let's see right here. Who's going to win? I like that right there. You got this, Rocky Top. Who's going to win right here? The next question. Which of the following is not a valid alternative hypothesis? What's up, Calzone? Calzone, if you want to join in. And we have a Kahoot after this, Calzone. Calzone, we have a Kahoot right after this. There's $50 first prize. I'd probably send it up to you in New York, or it's via email, so I could probably send it to you. It's an advanced Kahoot. Which of the following is not a valid alternative hypothesis? Who here can give a massive thing regarding this right here? Who knows how we instantaneously know this is not an alternative? We always say the something has the something. What do we know about the certain thing? What do we know about this? The null has the equal sign. The null has the equal sign. The null has the equal sign. So exactly, Victoria, right there. The null has the equal sign. So what is this testing right here? Who can put this into words? This is testing if what? And we have the three alternatives right here. The does not equals, the greater than, and the less than. This is testing if the what is equal to 0.36. So this would be a what question, because this is on the test. We should know. What is it testing? I get to talk about Taco Bell again. Everyone knows I love talking about Taco Bell. So, not a p-value. Good guess there, Morgan. Good guess. So what does the p right here stand for? We're testing if the what? The true proportion, Olivia right there, excellent work. The true proportion. We're seeing if the true proportion is equal to 0.36. And so this is a categorical variable right here, and we could say the proportion of people who like Taco Bell or the proportion of people whose favorite restaurant is Taco Bell is 36%. So we're asking a categorical question where people will respond either yes or no to it. So this type of question would be a one proportion z-test. This is a one proportion z-test where we have one categorical variable. So be able to identify just by the notation at least a little bit that this is a one proportion z-test where we're testing the true proportion of people who say yes or no to a question. The lockdown browser is from OIT Right. My laptop is being repaired and I'm afraid I won't be able to get back in time for the final, so I might have to use my dad's old one. The lockdown browser will load into pretty much any computer, so you should be good. Tell me if there's any issues. And we'll make sure we get it worked out. And that's the big thing. If you're watching this for another class, please email us as soon as possible if there's any issues, and we will make sure to get it working. Let's do the next question right here. Let's see. Is it still that 10 points? 10 points. I really want to know who wins this. I really want to know who wins it. This is so insanely close. This is astounding. With the next question, who is going to win? The central limit theorem states that the distribution of the sample mean will do what as the sample size increases? Need to get out of the way here. What will it do? Now, the central limit theorem is about as we increase the sample size, two things will happen to the distribution of the sample mean. And the two things that will happen are kind of like trying to like say the answer but not saying it. There's less variation in it. There'll be less variation in it. And also it will become a certain shape. I basically said both answers. So as we see right here, and I'm not blocking the right answer. So when we increase the sample size, we'll bring up the applet here. Let me do that while we're watching this. Let's bring up the applet and show it. So central limit theorem applet. How many people got it right? Not bad, not bad. I'm feeling pretty good about this. People are doing pretty good. So this is the central limit theorem applet. And you can take any distribution. And this distribution right here is what? Is very what to the what. These are things we should know instantaneously. Like if you take stat 1, you look at this and you say, oh, that's you could tell me probably 3 things about this pretty quickly. What would you say about that distribution right here? That distribution up there is very skewed. It's a unimodal right skewed distribution. Very unimodal right skewed distribution, which means the mean is going to be higher than the median. It's really nice right here. This blue line is the mean, and this magenta line is the median. And you can see heavily skewed to the right. Nice right there, Vincent. Excellent work. So this is a very heavily right skewed distribution, unimodal, because there's one modal area. There are outliers right here. So we can kind of talk about the shape center spread. It's best described by the median and the IQR. And they don't give us the IQR. That's rather sad. But with this right here, what are we talking about the central limit theorem? The central limit theorem says if we take 2 observations and average them together, it'll give us this blue dot. And we can take another 2 observations and get this blue dot. Does everyone notice how every blue dot is the average of 2 observations? Does that make sense that every blue dot is the average? Like, wow, was that pretty unlikely to occur? Does everyone see this blue dot over here? Was that blue dot, because we have to get this one and this one, that's about as extreme as we could get to get a blue dot all the way over here. Because if we keep doing this repeatedly over and over again, what are we going to build? We are going to build a distribution of the mean of 2 observations. And the distribution starts to look more normal. But what about if we go all the way to 25? Every single blue dot now is what? Every single blue dot I make right here is now what? Every single blue dot I get is now the what? And think about it, if you were to get a blue dot all the way over here, you'd have to get something ridiculous. Every single blue dot I get is now the what? Every single blue dot is now the what? Ooh, I found it. No way. Oh, that's just a black dot. Oh, so I love it. Every blue dot is the what? Well, it's not the median. Every blue dot, because remember, every blue dot is the what of all these 25 black dots. Every single blue dot is the what of every... I'll show it again real quick. Let me go back to the 2. Every time I make a blue dot... Oops, I did it twice by there. Every time I make a blue dot, it's the mean of the observation. Does everyone see? It averages those two together. So if I do this for 25 observations, it's going to take these and average together these 25 and give us one blue dot. So every time I take 25 samples, and then I get the average of 25. And if I keep doing this repeatedly, wait a minute, all of a sudden this very skewed distribution, which was not normal, starts to look more normal and wetter. More normal and tighter. It's all the way down there. It gets tighter and more normal. And this is the central limit theorem right here. I'm going to block it if I do that. But the central limit theorem states that it'll get tighter. If you notice right there, the black versus the blue distribution, and more normal. It's going behind my head right there. But the more normal is when it starts to look more unimodal and symmetric. Now, since this was very skewed, when would the central limit theorem actually work properly? Since this was extremely skewed, when would the central limit theorem start to work properly here? We need a sample size of at least what? Another review question. We need a sample size of at least what for the central limit theorem to really work? Abigail's right, 100. So the more skewed it is, like if you have something that is not so skewed, like let's go with this right here. Let's go and just go a little bit like that. Will 25 work for this? Let's go ahead and take 25 observations, average them together, and then do this repeatedly to make the distribution right here. And it's actually, it's hard to tell, but that is pretty normal. It's just because it can't make the bin width small enough. Oh, I should have made it here. Let's go back. Let's make one last attempt at this. We'll go here, and then we'll go a little skew like that. Cool. Now we'll do it for this. And if you look, that looks pretty normal right there. But this right here is not so skewed, and now we have a pretty normal shape right here. Not perfect, but looking a lot more normal. And yes, this is the central limit theorem here, that it states that it'll become more normal and tighter as n gets larger. Oh my God. Glad Oryx just totally no. Oh my gosh, I'm so sorry, Glad Oryx. Yeah, of course, Tyler, definitely. There's the code right there. I'm gonna stay right here for a moment. Join in the game, answer some questions. Let's see who's gonna win right here. You never know what's gonna happen. You never know. Glad Oryx is still hanging on there, but let's see who's gonna win right here. Who is gonna win with the next question? A confidence interval goes from 10 to 40. The margin of error would be what? I'm not plugging the answers. What would the margin of error be? I'm excited for this question. The answer is this. That's what the answer is. What is the margin of error? Always think of this in your head when you think of the margin of error, and then you can memorize the formula. What is the margin of error? Great job right there, Tyler. What is the margin of error like when we talk about it? It's what the length of the interval. What is the margin of error? What is the margin of error? I thought they're half the length of the interval, half the confidence interval. So the formula would be upper minus lower divided by 2. So if you, which is just the length of the interval is this, and then half the length, I'm putting it in the chat right now so people can see it, is divided by this. So the length of the interval is 40 minus 10, 30, and then half the length of the interval is dividing by 2. So this one usually gets a few people right here. What is the margin of error? Oh no, Charlie, no. Oh my gosh. We should give Tyler the median of everyone's points. That's what we do sometimes when we're missing values, Andrew. So interesting that you mentioned that. We actually substitute the median for missing values because it's a decent guess of what people would have. But who is in the lead? This leaderboard is insane. Usually you don't see it move around this much at the end. I think people are getting excited for the end of the game right here. Well, we're not. We're 2/3 in. And I have no idea who's going to win. I have no mistakes in the game so far yet. I'm really excited. Have not messed up this Kahoot. We got this going. Let's do it. Let's see who's going to win right here with the next question. True or false? Decreasing the sample size will make the margin of error smaller. My heart's starting to speed up. Decreasing the sample size. Please tell me I answered this one correctly. Oh man, so afraid on these. You guys think you can make mistakes on true false as I can too. So if we decrease the sample size, I'll show it mathematically here in a second. The answer is no. Who was in the lead before this question? Can you fix points in a Kahoot? Points for... It is false. It's 100% false. Let me double check my brain. I know we need the arrows on. I know, Epic, man. That's... Decreasing the sample size will make the margin of error smaller. I know, I made such a mistake here, Daniel. It's so easy to make a mistake when doing these. Decreasing... Here, I'll show you mathematically why it's false. Let me see right here. See if the Kahoot board changes. Oh, it's going to change. Oh, it's going to change. And fix... Let me see if I can fix an error in a Kahoot. Someone Google this really quick. Fix an error in a Kahoot. How report an error. There we go. Oh, man. It's going to change the board a lot. So the margin of error for an interval is this right here. So this is the margin of error for one interval right here. And take a look right here. With this right here, what happens if this gets smaller? If this gets smaller, what happens? If this gets smaller, what happens? If this gets smaller, what happens? I'm going to see if I can fix this while we... I wish they let you reassign. Let me try one last thing. Currently, I hope this doesn't mess anything up. 2 seconds, everybody. Trying something right here. My Kahoots. Edit. I'm not gonna be able to edit this question while I'm doing it. It's validating the Kahoot. I don't think that changed it. Okay. I know, right? What? Magic Hawk? We need to... So everybody got it wrong who's in the lead. Bronze Lemur. Okay. Let's make sure we're going to take a screenshot of this right here. 2 seconds. Class not over. All right. I'm take a screenshot of this right here. Okay, there we go. So I've got a screenshot of this that we remember who's in the lead right here. So this did not negatively impact the top leaderboard right here. So if we'll figure out what happens here at the end, but I'll make sure to make this up to people if not. So I wonder if I can fix it. We'll figure it out. What does everyone think we should do? Let's get some quick votes right here. Because I don't think I can fix it. Because I don't think I can fix the reports. Continue your reports. Oh, wait. Date. I think I have to wait till after it's done. My gosh, we played a lot of Kahoots. What? Okay, wait, I'm in the report. I don't think I can fix it, though. This is the question right here. Oh, I can see who got it wrong. 2 seconds, everybody. I don't think there's a way to reassign the question. Okay. Would it say start over? So a little too late to start over. I'm so sorry, everybody. Let's continue on right here. Let's see what the next question. No more mistakes from here on out. Let's do this right here. Who's going to win right here? True or false? Gosh, I not need to put true. The critical value for T for calculating a one sample confidence interval depends on the degrees of freedom and the confidence. So the true or false depends on the degrees of freedom and the confidence. The degrees of freedom depends, or the T depends on the degrees of freedom and the confidence. The T depends on the degrees of freedom and the confidence. What will the answer be? And then let's take a look at it. Very, very true right here. The T right here depends on the degrees of freedom and the confidence level. And what are we talking about mathematically? We are talking about mathematically right here, the y bar plus or minus the T with the n minus 1 degrees of freedom s over square root of n. So with this, when we change the confidence level, that's really the star part of this, because you can pick the confidence. And then the degrees of freedom are right down here. So these are the two things that will tell you which T you are using. The degrees of freedom are n minus 1 for the one sample T confidence roll. And then the star right here means you get to pick it, but this is relative to the confidence level. Let's see right here who's in the lead. We're just getting a shakeup of the leaderboard. Bronze Lemur is in the lead. I might do something crazy here at the end due to the mistake. I might do something crazy. We'll see how the leaderboard stays. I have a snapshot of how it was. So let's continue on right here. I've got a Kahoot right after this, but we got Cyril, and let's find out who's going to win right here. The T distribution is like the normal, but is different in what way? How is the T distribution different? Here's the hint. I pay the fool. What is it going to be? How is the T distribution like the normal, but is different in what way? Let's see. The T is just like the normal, but it's been smashed down. So there's more area in the tails. So when you take the T right here, so we have the T distribution, or the normal, and then we smash it down to make it the T. And you know what? Oh no, Victoria, no. No. Let's go to stat distributions T, and let's take a look at this. So here is the T distribution, and here's basically the normal. With less degrees of freedom, it's going to be more smashed down. And if you notice right here, the tails are thicker on the T, so there's more area in the tail on the T, but as we get more degrees of freedom, it becomes more and more normal, and we see basically the normal distribution, which is like this right here. So the T is very much like the normal, but it is just smashed down. There's more area in the tails. Who is going to be in the lead? Let's find out right here. Whoa, talk about a shake up the leaderboard. Bronze Lemur still in the lead. With oh my gosh, crazy shake up of the leaderboard. Couple points separating everybody out here. Let's continue on. Let's find out. And we've got a screenshot. I'm going to take a look at what we have, and we will figure out a fair way to div everything up. Let's continue on. Let's do this. When the p-value is below alpha, what do we do? Oh, this one Sheila should know. When the p-value is below alpha, Julio was given some hints earlier on. Julio knew the answer to this one right away. When the p-value is low, do what? And what do we mean by low? We mean lower than alpha. There's a lot of things on here we would never, ever, 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 ever say. We would never say, I accept the alternative. We never accept the null. There's only one right answer on here. I could have put the other possible answer. But we only reject the null, or we only do what? What are the only two things we do? We only reject the null, or we do what with the null? We only reject the null, or do what? What do we do right here? We only reject the null, or we only do what? Fail to reject. So, and then if we reject the null, we have evidence for the alternative. If we fail to reject the null, we do not have evidence for the alternative. So very important to know that we never say things like I accept the null or I accept the alternative. We just say I reject the null when the p-value is low, or I fail to reject the null when the p-value is not low. And that's when we have evidence, is when we reject the null. So if the p-value is below alpha, we reject the null. And what is alpha usually assumed to be? Without any other things to know, alpha is usually assumed to be what? And this is the point when we reject the null. The point at which we reject the null usually is 0.05 without any other suggestions, but someone can specify alpha for us. Is everyone ready for this, the final leaderboard before the finals? Oh my gosh. This is absolute insanity. How was it before the shakeup? Or there we go. It's pretty even right now. Let's find out. Everyone on the top leaderboard got hit by the shakeup. Bronze Lemur leading the way. Let's find out right here the final question. But we have a special guest right here, everybody. Who knows who the special guest is going to be? I need someone to guess who the special guest is going to be. Who knows? I need some guesses in the chat who the special guest is going to be to help us out.
I'm Tiny Brian. I got my voice all crazy. Tiny Brian is here. So Tiny Brian and his parrot. You probably didn't know this about me. Tiny Brian. I'm a pirate. Let's do this. Final question time with Tiny Brian and his parrot. And Francis. Everyone knows Francis. Thank you, Victoria. So here we go. Nikita knows Tiny Brian's here. Let's do this. Tiny Brian's here. Pirate Tiny Brian goes to the doctor. The null is that he doesn't have scurvy. What is a type 2 error? So much text on the screen, I had to be Tiny Brian. This one says right here, he does not have scurvy, and the doctor says he does. So, a type 1 error is when the null is true, and we reject it. A type 2 error is when the null is false, and we fail to reject it. Large Brian will come back here in just a moment. But we're looking for a type 2 error. Null is false, and we fail to reject it. Oh. Brian's praying he picked the right answer. Oh, gosh. Francis, do you know what the right answer is? Francis, why don't you fly over to the right answer? Francis, help us out here. Francis, what do you think, Francis? Oh my god, Francis. Where are you going, Francis? Where's the right answer, Francis? Francis. Oh, there we go, Francis. Nice job, Francis. You got the right answer. Francis, got the right answer. Here, let's go back. Tiny Brown's got to go away. Tiny Brown!
Oh, now I'm acting normal voice. Now I'm over here. Oh my gosh. This is what happens when we have so much craziness. But remember, okay, everyone review right here. In a type 1 error, in a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. So remember, the null is that Brian does not have scurvy. The null is that Brian does not have scurvy. Does everyone see this? Thank you so much, Tyler. I appreciate it. I really just hate that. I'm like, how can I fix this? We're going to fix it up here at the end here. We're going to make it good with everybody. Don't worry. I'm probably just going to add some additional prizes, I think, to it. So let's do that right here. Thank you so much, Andrew. Let's throw some additional prizes. We're here for fun and we're here for learning. But I want everyone to do this with me one last time. You ready? In a type 1 error, the null is true. So in a type 1 error, it is true that Brian does not have scurvy. Thank you so much, everyone in the chat. It is true that Brian does not have scurvy in a type 1. And let's write this out. Let's write this out. And everyone's so much positivity. I love it. So we got Francis in the chat right there. I love it. So in a type 1, let's write this out. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. Okay, so with this right here, I want everyone to just think this over for a moment. Let's look at a test right here. Francis, you got to go away. You're blocking the screen, Francis, right before we find out the winners. So, you guys are awesome in the chat. So with this right here, let's look at a null hypothesis like UT will win. Okay. So, and then UT loses. What is a type 1 error in this instance? What is a type 1 error in this instance? So I want you to look at it. In a type 1 error, the null is true. So I want you to look at that null and think that that null is true right there. So what is a type 1 error in this instance? What is a type 1 error? In a type 1 error, the null is true. Exactly. And what does that mean then, Charlie? UT will win. UT does win. So UT, we could put here UT wins as the null. UT wins is the null. So UT wins is the null. UT win. UT wins. Exactly. And then what does it mean that we're rejecting it, though? So what does it mean that we reject that UT wins? UT wins, but the rest... Hello right there, Alex. So the null, in this instance, in a type 1, the null is true. So UT wins, but we believe that UT will lose. We reject that and say we have evidence UT will lose. Does that make sense? In a type 1 error, UT wins, but we think they will lose. Like we're saying, I reject the null that UT will win. I have evidence they will lose. In a type 2 error, the null is false, but we fail to reject it. So the null here is false, and we fail to reject it. So in a type 2 error, we think what? Remember, in a type 2, the null is false. Does everyone see the F right there? And we fail to reject it. So this is false, but we fail to reject it. So what does that mean in a type 2 that is the null is false? So it is false that UT will win. UT will actually lose, but we believe UT will win. So UT will lose, but we think they will win. Exactly. This is really good practice right here. And this is the one we just did right here with scurvy. So the null, if you go to a doctor usually, is no scurvy. And the alternative is going to be scurvy. So the null right here being scurvy and the alternative being, or the null being no scurvy and the alternative being scurvy. So what do we have right here? In a type 1 error, the null is true. So tell me what is true about this individual in a type 1 error. In a type 1 error, the null is true. Type 1 is controlled by researchers, controlled by alpha. So this is controlled by alpha right here. That's controlled by alpha. And this one's controlled by alpha, sample size, and effect size. And those are all inversely related. So in a type 1, what is true about this individual? Tiny Brian does not have scurvy, but they treat him for it anyways. Exactly. Great job right there, Tyler. He doesn't have scurvy, but the doctor thinks he does. And then a type 2 error, the null is false, but we fail to reject it. So in a type 2 error, it is false that he does not have scurvy, but we fail to reject it. So we continue to believe that he does not have scurvy, but that's false. He actually does have scurvy. So that's why I sometimes call type 2 a false negative. My gosh, good work, everybody. This was like a power hour of learning. I'm going to be doing the 320 material. Is there a Quizlet for exam 3? I think so. Is it not posted to the, maybe I'll post it to the site. Email me Rocky Top and remind me and we'll get it posted here. But we should have a Quizlet, or if anyone has one, let's get it posted. Let's see who won right here with the prizes right here. Let's find out this final podium. With 13 out of 15 questions, Bronze Lemur. Excited Emu. And right here we have in first place. Oh my gosh, they reverse. Nimble Elephant. Let me see the previous leaderboard. So Bronze Lemur, we had Magic Hawk, and Excited Emu. Excited Emu still came in second. Diplomatic Eagle. You know, I think it was, who is it? So Magic Hawk is not on the leaderboard. Magic Hawk, I want to give Magic Hawk 20. If you're Magic Hawk and you're still here, I want to give Magic Hawk 20 because they were on the leaderboard and then they got knocked off. So Magic Hawk, I want to give you 20 right here. So, because I promised, you know, some big prizes tonight. So Magic Hawk, you were at the leaderboard at the top and then you got knocked down with that question. So Magic Hawk, I hope that makes everything right. They're the only one I see right here. Bronze Lemur jumped up. Magic Hawk was up there. Excited Emu placed and Nimble Elephant placed. You know what? Let's give Diplomatic Eagle 10 right there. So they all got it wrong, but it was a right question. So does that make sense to everybody? How's that sound, everybody? We did some extra prizes right there for everyone who was on the leaderboard at that point. So it's for fun, but please email me if you won. But to everyone here right there, Magic Hawk 20 and Diplomatic Eagle 10, email me with your picture of it. I think I got 11th. Oh no. We're going to head over here to the other stream in a second. Let's do this. Who wants to hop over to the other stream and say hey to them? And hopefully, I've had issues with streaming immediately after. But let me drop this in the chat again right now if you're watching. These playlists right here are very, very valuable to learn. I got fourth, but the other question wrong too. Oh, no, Zach, sorry, Zach. I think everyone got hit by that wrong question. That's why I kind of did with what the leaderboard was, because everyone just kind of got hit by it. Does that make sense, Zach? Like everyone got hit by the same wrong question. And so it's kind of, you're welcome, Meryl. You're welcome, Meryl. So Magic Hawk, were you Magic Hawk, Andrew? Oh, that's awesome, Andrew. Great job right there. So Magic Hawk got some points right there. You're welcome, Zach. Thank you so much. I'm going to drop the other Kahoot. Yeah, jump into the 320 Kahoot. Let's do this. Let's do this. Let's jump into the 320 Kahoot. So I'm going to put the link in the chat right here. Hop over to the other Kahoot. We got 22 people waiting. Woohoo. Be here soon. And so let me jump in right here. Okay, I'm dropping it in the chat. Oh, totally flex your points. You know what's going on. I'm going to end this stream right now. So I'll be seeing everyone soon. Let me end this stream. I will see everybody. Hop over to the other stream. See you soon. Bye for now, everybody. Bye.